today we are going to discuss the problem of finding the nearby services, businesses, or call it a more of a, like designing a proximity service. It has multiple use cases like in Swiggy, Zomato, or like in DoorDash and all. You might have seen like once you log in for a particular location, you will see like all the nearby restaurants. The experience is something like this, where by default on home screen you see some of these uh, the restaurants and all of those things. The first criteria is basically the nearby restaurants, like based on the distance, like within a let's say 5 kilometer or 10 kilometer radius. Then there could be some other attributes like how you are seeing the restaurants or the businesses and all of those things. Those attributes we are not discussing. We are focusing mostly on the location oriented thing. Similar thing you might have seen in the Uber Ola also, where like once you kind of log in or you kind of see the nearby drivers that are there, like all the cars of a particular type and all of those things. So the again here the first of the filtering criteria is the location or the distance between the user's location and then the driver's location, and then it kind of shows within a particular radius. Here like in Uber and Ola it might be showing for a smaller radius and all of those things depending on how many are available. Similarly, like the third use case that you guys might have seen already quite a lot is the Google Places, where you can search for anything like restaurant, petrol bunk there. In all of these, one of the common thing is the for a given location, find all the nearby places. We are going to design the proximity or the nearby service, right? We'll quickly go over the requirements, the way we follow the requirements and everything in the other problems that I've recorded. Cool, let's get started. So yeah, we have to design a nearby service. Let's go through the functional requirements first. So first is given a location, let long find the nearby places or businesses in the radius of k kilometers, or for example 5 kilometers. All right, so this is your first and foremost requirement that is there. Let's say the NF. Let's just talk about the scale first. Like what is the order that we are thinking of? Maybe like there are 30 million places, like businesses are there, right? Or I mean it could be even more, but maybe like then there are different types of the businesses, like maybe total number of places. If you are saying let's say 100 million places, and then maybe like 20 million of each type, right? Something of that sort. And the number of users could also be very high. Here let's say the Uber and Ola and all of those guys, they do have users in the 50 to 100 million domain, like of the range of 50 to let's say 75 million users that are there, right? All of these guys are kind of querying. The queries are coming from everywhere, so you can say like this is basically everywhere that is there. Let's quickly write down the NFRs. The first thing it should be, which is basically like the searches should be quick. What that means is high latency. The latency of the query should be low. The second one could be like the system should be able to scale up. Scalable system, right? Because burst of traffic could come in, because by the nature of the business that you are in, it would depend on like where was the kind of traffic pattern is. Like for example, in the Swiggy and Zomato kind of services, you will see a lot of the traffic that is coming in the morning, evening, afternoon, like when people are ordering the food. But the system should be scalable, like it should be able to handle all the system, right? Here, as you can see, it's like read heavy systems. The business mapping, like for example here, let's say business mapping changes are getting handled. Business mapping changes, what that means is business location changes are getting handled. And these business changes are not getting handled in the real time, not in real time. There could be something that is there. So here, like we kind of first go through one problem and then we'll go through a couple of problems. What you can say is like here in case of for the Zomato, Swiggy and places kind of use cases, right? It's a read heavy system, which is basically there are a lot of read queries that are coming in. Changes in the locations aren't that frequent, right? But let's say the Ola Uber use case where the cabs and the location driver locations are changing frequently, right? So the write and read might be of the same order, right? In this kind of use case, we have to handle the updates in a better way, right? Updates are not there. So these are like NFRs, business map, business location changes are handled correctly. So we'll actually go through one by one, like one use case by use case. What this means is like all these businesses scale and all of those things. We'll first start with the one problem, which is, let me just kind of write down here, use case one, which is where the reads are much higher than write, like Zomato, Swiggy, Google, places, right? This kind of use case, we'll go about it first. Here in this use case, you will see like the first thing is what is the core entity that you have. So core entity would be your restaurant, that would have like ID, name, or call it a place for simplicity, name, and then it has the latitude, and then there is a longitude, right? Latitude, longitude, and then there is other metadata which we don't have to worry about for now. Metadata, and then there will be a user, right? Which is fine. I mean, that is not a core entity. And then API, what we are designing is maybe, let's say, the get API is there, which is the nearby places. It's providing you the length, let A, and then longitude B, and then maybe the distance, like radius, right? So this is what the API would look like. It's a simple API that basically returns the list of places, maybe like sorted in the order of distance from user's location, right? So these are our simple APIs that are there. Now what you can do is, like, let's say the restaurant or places table is there, which is having, let's say, the 20 million entries that are there. What first thing that you could do is, like, one of the brute force approach that you might think about is like, can I just make it an index, like, for example, this becomes your primary key, right? And then here I kind of create a secondary index, and this again the index that I can create, right? Simple, like, why let's say whenever this API comes in, I kind of do that select star from restaurant table, where, let's say, I can put, right, where, like, r dot let is less than equal to something like let that user has passed, and then the radius, something like this, right? These kind of queries I can do, and right, which is basically, and something similar for the longitude also, right? There would be so, right, something of that sort. This kind of query I can do. Typically what I'm trying to do here is, let's say this is the map that is there, right? My location is here. Let's say these are my long and let that have been given. Now what I'm kind of doing here is finding the places that are there in this radius, right? Let's say this is 5 kilometer, right? So this is what I'm trying to find out. What I'll do is, like, all the restaurants that are there, which are already there, that has a latitude and longitude, and I'm kind of doing the figuring out from this particular point, right, to, like, there are some businesses here, there are restaurants here, and all of those things, right? Let's say there is a restaurant here, and all of these restaurants that are there. And what I want is, like, all the restaurants in that particular radius. What I can do is, like, from every point, what I'm trying to do is I'm kind of trying to find out the restaurants using this particular thing, secondary index. But one of the biggest problem here is basically, like, this is a what do you say? Let me just like, with this particular query, what will happen is, like, first you are kind of applying the filter clause on the latitude and then the second on the longitude. So what you are trying to kind of do is, let's say there is a something of this sort, right? So this you have kind of what you want is what we want is basically the restaurant that are there in this area, right? This is an intersection of the, let's say this is my let's say this is the x-axis, right? This is y-axis. But what will happen here is like this won't kind of give you the what do you say, the like this kind of query, like it can indexes are better optimized for like one dimension, like for one dimension. So it can either filter out for this x, let's say the latitude in this direction, like it will find out, but it will not be able to do the same query again on this one. So what will still happen here is, let's say the this where clause kind of whatever I have added, and then where clause on the latitude, where clause on the longitude. This will kind of, let's say first on the latitude it will filter out these things, but then it will, you have to do the one by one scanning of these things. And now because it's 20 million entries, or it could be even more, this will cause a problem. So how do we solve these kind of problems? Right, there are other things like better DBs for storing this map data. Right, so you can have those geospatial indexing, which is basically it will try to create those geospatial indexing. Right, let's say the Postgres has this extension PostGIS that could be used, where like you can store all of this data, which will be stored in a slightly more optimized way, and it will create the geospatial indexing. Basically, like instead of one dimension, it will create the indexing two dimensional indexing. This PostGIS extension that helps you create that indexing, but on the origin, like just the Postgres alone, it doesn't work. And similarly, for there is a Redis also has a similar way of storing the geospatial data, like the geo data, and then you can do the queries and everything. Right. So those could be utilized, but there is a better solution nowadays. What gets used for these kind of queries, slightly more usable. So what that does is basically we call them geohashes. Right. So what this means is, like how this idea came in was, we know, let's say this is the map that we have, right? Let me just delete these things. Let's just have them here. We'll kind of move here, right? For example, there is a map that we have, like whatever the map that we see. So the simple one was kind of how can you create the smaller grids, right? Grid of up to a certain distance, so that it becomes much easier to kind of search, especially in the nearby search cases where we don't need the exact location, like exact finding is not required, but you can quickly just do the simple searches and all of those things. So what that means was, like the geohashes concept came in. What it do is basically divides the map into the two parts to start with, right? So let's say, and then this is maybe like 0, this is 1, and what it will do is, like this is the entire map that is there, it will divide like this. And then because this is such a big one, so what it will do is it will divide it further, right? Basically, let's say I start the but 0 0, something like this, right? 0 1 1 0 and 1 1, right? So these are the four areas that are there. Now what I can do further is, let's say I kind of divide this one into further pieces, right? So this will become maybe, right, again I'll add it 0 0 1 0, right? This is my becomes 0, right? You got the idea. 1 0 1, then it will be something like 0 1 1. All of those things could be done. I mean, I'm just using different one, but basically what I'm trying to do is, wherever you have bigger places, like wherever you need like slightly smaller, like what we were doing in the geospatial indexing was this nothing, or like how would you define a tree, like to find out in which area the particular location falls. So basically I can divide this further, right? This is again an idea of dividing the uniform, what do you say, like I can keep on dividing this one, and then I can find out. So this is the concept of the geo special indexing also, like it stores it in a different way. Like for example, Uber has also built not in the square one, but using the hexagons and all of those things. So there they have the H3 uh, indexing way that they have implemented. But this is basically like geospatial indexing, what it has been done. But in the geohashes, what has been done is basically you kind of define all of these in the uniform way, right? So there is a, like, the entire map is defined like this, and it has been distributed, uh, right? For all of these, like there'll be something 0010 something. I mean, ignore the number, whatever is there. But basically, like you can represent all the grids with a unique uh, byte code, right? In the bits you can divide it, and you can keep on dividing the map into a particular, like whatever the granularity that you want, right? So what that basically means is these geohashes, they use the same, this concept of dividing the map, and basically let me just kind of come here. What this means here is, let's say the for a particular grid, like this, these are the some bytes that are there, like you can identify a byte using something of this sort, right? This becomes your, let's say you have kind of went on to dividing the grids further at a lower granularity. So this is your uh, base 2, right? Basically in the binary representation, this is how you can identify. But there is a better way if you kind of start doing that. So maybe like you can kind of divide it into the base 10, which will be the numbers, right? 0, 1, 2 and all of those things, right? 0 to 9 numbers you can divide it. Then maybe you can even use the alphanumeric, right? Maybe like convert this into the base 32 method. So what this does is basically you can kind of keep on defining this one, and it becomes more like a q something, right? 2 3, right? So these are the kind of like this unique string could be created to identify a particular like this is basically nothing but your geohash, and that can identify a grid on the map that is there. Let me just take one example. What this means here is, let's say sorry. So I can kind of find out I mean this is a different use case though, but basically like for the simplicity, like this is a grid on the map. These are the like is has to do is, let's say when the grid is divided, grid geo has length is 1, that means the cell height or the grid that you have divided, that's the size of that is 5000 kilometer by 5000 kilometer. But hash of size 5, it's basically a grid of 4.89 by 4.89. And then you can go further also, like 6 digit like 6 character hash would have this much, and the last one, which is like 12 characters long hash, will have 37.2 mm by 18.6 mm, which is really small, right? And then there are like this is very standard, as you can see from here, like how we are converting the binary to the base 32. So the other way around is also possible. And this what this library that is here, when I give the latitude and longitude, it basically is able to figure out which grid that latitude and longitude belongs to. And basically I can figure it out in a O1 use case, the first use case that we are having, let's say, right? So let me just kind of take the restaurant table here. Okay. Okay. So what I'll do is, like restaurant table is there. What I'll do is maybe the restaurant to restaurant grid mapping, right? What I'm doing is, it will have the restaurant ID and then the hash corresponding to that, right? What I mean by that is like geohash, to which geohash it belongs to, and that we can find out from the latitude and longitude. And maybe like here itself we can just have the store. I mean, depends on like if we are using the database, then we can kind of find out from here. But let me, for the simplicity, I can just put the latitude and longitude here also. Though we are having it here, we can do the, what do you say, the joins also. But for the joins of 20 million entries might not be a good idea. So or like we might not be using a what do you say, a database, the SQL database. We might just be going ahead with the Dynamo and all of those things, and there we can have some more denormalized data along with this particular thing. So now when the request comes in, what will happen here is, let's say the, again, our system design would look like this. right? This is my I'll still have the load balancer, because right, I mean there could be multiple services that we'll be having, and we'll utilize it in the upcoming use cases also. So load balancer, the API comes in, there is a DB here, right? Let's say this is a DB, could be anything, and then we'll have these two tables here, right? This is a nearby search service, nearby service. What it will do is when the API come in, it will go here, it will kind of go to the DB, do a query. What it will do here is, for location, user location, find the cell that it belongs to, right? Or the geohash, right? As you can see here, let me just bring it down here. Right, let's say you come in and your cell belongs to this particular zone, right? Now what could happen is, like, though here for our use case, let's say the 5 kilometer one, we have taken the for 5 kilometer, the radius is 4.89 kilometer, right? Sorry, the size is grid size 4.89 kilometer. So this would be good enough for us, like this. The geohash length of 5 should be good enough for us, because we are not going below that. Even if we are, we can kind of that we can figure out, right? So what has happened here is, like, we have kind of defined this one. This is a 5 kilometer by 5 kilometer. This gives us this one. But one single thing would be, let's say this point is in between, then we can kind of find all the things. But what happens when this is on the let's say the restaurant, instead of being here, is kind of on the border of a particular grid which it belongs to, right? So in this case, it might be possible, because we are asking for the nearby restaurants. The restaurants are in the nearby grids. So what happens here is, basically the query that you will write would be something like, for example, and this select star from restaurant grid mapping, where let's say the geo has like point geohash, right? So what I'm doing here is kind of the point geohash is basically the let long get converted to the point geohash, that is simple one, and then I'm making a query which is basically doing a like query. So before I go to this particular query, what happens is, basically, I mean this is a better visualization of what this means is, first thing is, like, we find out in the cell what are the restaurants that are there, but it might be possible that the restaurants are, or the places are in the nearby grids also, because these grids are 4.9 by 4.9 kilometer long only, but they could be in the neighboring ones also. So what we kind of do is, we kind of make use of the nearby grids also. So how that could happen is, if you kind of go back here, like when we are converting these into the grids, like the entire map into the grids, and then converting it to the hashes, they are more or less the same, right? The 5 characters could match, right? If we are kind of figure out the 6-digit hash, like 6 character hash, all of these hashes are more or less the same, only the last few characters would be differing, like in the neighboring ones, except what is on the equator and all of those things. Those we cannot ignore. That is one of the limitation of the geohashes, where this like kind of a query wouldn't work. So what is happening is, all the neighboring grids would be having the same prefix, and we can kind of utilize that to kind of do the like query. So this gives us the restaurants that are there, and then now we can kind of figure out the distance, and then return the places in that much, like in the order based on the pagination and all of those things. So this is what the geohashes are, and this makes it much more easier. And now there is no need of a special type of the database or data structure and all of those things, or your single geohash would be able to help you. And here you can kind of create the index, right? This index would be quite easier because it's one-dimensional index, right? And now I can filter out these things. So this is how the nearby service would work. So coming back here, which is the NFR latency should be low, we have indexed it and all of those things. If there are many other types of databases, then maybe there could be some more indexes here. Instead of applying on all the 20 million entries, we can do some more optimizations. But the idea here was that geohashes handle correctly. Now let's say if the location is kind of changing, right? The nearby service, for some reason, the places have been changed from one place to another place. In that case, what will happen here is the same. Let's say the update API is there. update API. What it will do is it will go to the nearby service. It will find out the new grid that it belongs to. It can kind of make the changes in this table and also in the second table. Right here we haven't used any caching or anything for now, but that also we can kind of utilize and do this particular thing. So the simpler ones could change here because we are writing it into the DB. It's not because the write queries are not way too many. But similar kind of use case would be there. Like this would help you solve the cases where the locations of the locations are more or less static, right? What could happen in the use case number 2? Use case number 2, right? Where let's say the driver's location is changing frequently. What this means is basically here basically the driver is sending their location every 5 seconds, right? Again, what will happen is we'll kind of utilize the same thing. Only thing is that it will be, we have to define the same flow would be utilized, but the thing would be we'll have to kind of define, let's say here there is a queue. I mean that just keep, okay, let me actually move it this onto here so that we can make it slightly easier. Okay, we'll just do this. So let's say there is a driver location aggregator. So what happens here is, let's say there is a load balancer, driver sending location. Okay, this API is there, it kind of comes here. This location aggregator service, what it is doing is kind of latitude and longitude that is there, we are pushing it, writing it into the queue, right? And then there is, let's say, a processor that we'll put here. In the above one thing that I didn't do was let's say the location processor, right? All the events that are coming in from various DEs and all of those things, and it will kind of aggregate and start writing it here. Makes the changes into the DB, right? So what we can kind of do here is maybe this is becomes here in the DB. I'll have like that kind of, because there could be like a lot more DBs that are there, repeat reads are there, like read replica, right? Similarly I have the read replica here. This is kind of goes here, and even the earlier changes I was doing here, and then either the changes could come in from here, and these basically are maybe like reading from these various read replicas, right, that we are having. So nearby service that is there, maybe like the update API will kind of move it here. Location changes, it goes into the queue, or it can directly make the changes into this particular thing. So this is a write DB, right? Or you can call it a master instance where the reads are kind of going to one single node itself, and then we have like multiple read replicas, and from where like the nearby service is being powered up. And here like a lot of all these geohashes are kind of if we go slightly more into the scalability part, geohashes could easily be started, right? We can distribute it because it all depends on the character, like which part of the map it belongs to and all of those things. So they are pretty scalable. We can here basically like why I chose the location process, like so that all my writes are going into one DB itself, and we are reading from the read replica so that the consistency is not causing a problem. But those also we can change depending on, like we can make everything, every node or every instance as a read and write both based on the SARD, and then we can kind of go and keep on changing the locations and all of those things. And what will happen here is basically this is changing the location, driver and geohash mapping, right? And then as this is coming in, whenever the request that is coming in, we are kind of reading once the data is replicated, we'll get the updated one. But till the time this mapping is not updated, we'll get the earlier data itself. There could be multiple ways here, like you can just have multiple nodes for write and then their read replicas, and that those write nodes are kind of replicated. All of this could be done based on the however we want to do the scalability and all of this. So that's the kind of strategy could be used in the Swiggy or Zomato kind of use cases, or even in the Uber Ola kind of use cases. One thing is Uber has kind of built their own version of the geohashing or the geoindexing. Instead of the squares, they kind of use the hexagons. There are a few other implementation where people use rectangles, and hexagons kind of gave you slightly better uh, finding the neighbors and all of those things. But the idea here is basically geohashes makes it much more easier. There could be like a lot more optimization that could be done here. If the idea here was to kind of explain the how geohashes work and how we can scale it or deal with the geo kind of data, the map data on the simple databases, right? Yeah, so that's about it. There could be a lot more optimization that could be done here in case of the location, processor, how it happens, and all of those things. Cool, thank you. If you're liking these videos that I have recorded so far, please like and share these videos that I've recorded for various system design problems. Also subscribe to the channel. Feel free to comment on these videos with a topic that you would want me to cover, or any specific system design problem that you would want me to solve and record it for you guys. I would be happy to do that.